Okay, now, so far that we have seen that what do we mean by the priors on the R stand arm, I should say on the R. Now let's go ahead and let's visualize the priors, and also let's see how can we just manipulate the priors, which apparently it has been decided by the R itself, and it has been, I should say, scaled. And also let's see how we can just visualize it in terms to see that if we can just make some comparisons. Let's talk about that, visualizing the priors. Okay, but before to just go to do that, let's go back to the model that we had before. I'm just going to copy paste it, bring it down here, the model A, which essentially it was one of the most simplest regression analysis that we have done for only one single variable inside the R. Okay. If I just press F1 and I have, I should say, the help menu just to opens, we will see that we have in the help menu there, if you scroll it down, you see that one of those arguments that we have, there are some indications of the priors. You see that here it's going to be almost at the very bottom of, let's say, the arguments. We have these ones which we're going to talk about these three ones. And the next one, we're going to talk about the prior PD, which stands for the prior predictive distribution. It's going to be the topic for the next tutorials. But let's now focus on the priors specifications that we have. You see that as a default, the prior, which is going to, it stands for the priors for the coefficients of our covariates. It's essentially, there's a default prior which is going to be the normal distribution. But let's see if we can change it or not, depending on the knowledge that we have about the priors. For example, imagine that right now here, I'm just going to come here to just type prior. And I'm just going to just go ahead with that. For the prior, I'm just going to define the prior that I have in my mind based on the knowledge which I have from the prior research which has been done on that experiment, or from the prior assumptions which I can just incorporate into my experiment then. Now, if I just put, for example, as a normal distribution, that I have the freedom to just choose the family of the priors which I have. Imagine that for the normal distribution, imagine that if I assume that it's going to be, let's say, for example, 4 as the location, and also let's assume that it's going to be 1 as the standard, I should say, the scalar that I have. Okay, now, it's going to be 4. That's how I just define the prior for my coefficients. And also, I'm just going to go for the next argument, the prior intercept, which is define the prior for the intercepts. I'm going to also choose that as a prior, which is going to be, I should say, centered at 1. And let's say go ahead to the 15 as deviations from the mean. And also, from the prior for the auxiliary, let's say as ahead, we just go ahead with the exponential. And I just put the rate equal to, instead of 1, which is the default, I just put the 2. I'm just going to go ahead to just run this model. And let's see, as you can see, that it's going to run. It goes all the way to the chain number 4. And before we just move on, sometimes also you have the freedom, sometimes if you have multivariate regression in the Bayesian, you can simply just go ahead with the, let's say, for example, to say, okay, chain equal to, let's say, for example, 1. And you will see that it takes fewer time to run the model, but somehow you may have, I should say, when we just go to the diagnostic phase of your Monte Carlo, then you may have some kind of problems. Then when you just get to the diagnostic phase, we're going to talk about that thing then. Then at this stage, you see that we can also manipulate the number of the chains that we had. Now, listen, okay, now as long as we are here, let's go ahead to just study the priors that we had for this model. We'll randomly choose the priors, and now let's go ahead to see that how we just see the prior. Now I'm just going to go ahead as an object, put the name of the model which I had. It's going to be model A, the Bayesian model which I had. I'm just going to execute it by pressing Control Enter, and you see that I have some descriptions of how the model has been decided on. Okay, for the first thing, you see that for the coefficients, I decided the normal distribution with the location 4, which is going to be the center, and the scale 1. And for the intercepts, you see that it's going to be the exact same thing. And for, I should say, for the auxiliary, we have the same thing. Also, you can come also with this idea that when you have, let's say, these priors chosen, you can also visualize your priors based on the functions that we're going to talk about. That we are just going to talk about the prior, and also the function which I'm just going to use is a kind of it is now for the visualization of the prior and the posterior, just both at the same time. And that's the thing which I'm just going to do. In order to do that, I'm just go ahead with the function which I have there. As you can see, it's going to be the prior, and I have here posterior, and I have also the prior. You see that the posterior versus prior, that's going to be the thing which I'm just going to do it right now. I'm just going to press F1 to see the help menu which is open at this tab at the global environment. And the thing which I have to do, as you can see, the object which I have to just make is going to be the first thing, which is going to be my model A, which is going to be our Bayesian intercepts, which is going to be our Bayesian model. The other thing which I'm just going to use, I have two options to do that. I'm just going to go ahead with the parse. With the parse, I have two options to do. Either I can just put the beta, which shows, I should say, the priors which I have for the coefficients, not for the intercepts, and I have alpha for the intercepts. I'm just going to go back to the next. Well, I'm just going to come back on the next the thing to just change the parse to the alpha, and also I'm just going to go ahead. As you can see, the prob is going to be 90%, which is a default. I'm just going to also put the color, which is a color by. I can just put it as the way which is a default. I have versus. It's still a default one, and I have also none. You can go ahead and just read the help menu in case if you just want to change it. And it seems that we are totally fine, and I'm just going to go ahead to run this model. And it takes a couple of seconds to run this, and we are going to have, let's see what's happened there. It seems that we have an error passing unknown arguments to chain. Okay, let's remove the chain from the things which we had done on the top on the model, and execute, rerun the model again, just run it with the for chain. And now I just come back here to just run the posterior versus prior command, and I'm just going to run it, execute this. It takes a couple of seconds, and now you will see that the model is created. I'm just going to zoom on this plot to see that what we have done. Okay, you see that on the posterior, the inference that we made, it was for the weight. If you remember in our model, the weight that we just made an inference about, it was about 0.3. It was the slope of our covariates in a linear model, which it was weight. And you can see that on your prior, you are so far off from the things that you have done that. Essentially, you will see that the things that you have done, it's going to be a kind of a guidance that how you are far away from the thing which you had just made an inference on. And now if I go back and I change the parts from beta to the alpha, I can just go ahead and just have the visualizations of, let's say, the posterior, the inference which I had for this slope, which it was essentially around 15, if you remember, and the prior which I have here, which essentially you see that the intercept, it's so far off from the things that initially we had it when I just choose the prior which I had it on my model. Then now you see that whenever you just come here to work with the different priors, you can always come and say, okay, to visualize it. And the other thing is that sometimes For our model, we can just go ahead and just put, for example, the null, in terms of if you just want to have a complete non-informative prior, as you can see that I'm doing it right now. If I just go ahead and run the run my code, the Bayesian regression, you will see that if I just run the prior summary, you will see that for the intercepts and the coefficients, I have a flat prior, which it means that the priors that you are incorporating into your model does not bear any additional information, and it has no impact and weights on the posterior inference that you have for, I should say, for your measurements. Although you will not use normally a flat prior, it's recommended always to just go ahead with something which it has some weights on the posterior, but I just wanted to show you that if you just go ahead with that, how you have the result. I'm just going to visualize it, the posterior versus the prior, to see that what we are going to get from the visualizations of the prior with respect to the posterior. And as you will see, because I have the parse argument in the posterior versus prior as the alpha, I'm just going to get my intercepts of my model to be visualized as a posterior versus the prior one. Let's see, it seems that the model is still running. Let's give it a couple of seconds because we just put the null. It takes some more time to have it executed. I just give it some time. I'm just, oh, okay. Now it seems that that's now ready. And now you will see that, okay, you have a huge uncertainty and still you have around 15 for the posterior. And now let's go back to change it to the beta to have the visualizations for the slope. It takes a couple of seconds because we decided to just go with the null, a flat priors for both of the intercepts and the slope, and it takes a sampling algorithm to just convert to one point into our, I should say, the parameter space, and that's why I should say the model takes longer than what is expected to just get to a point and also to have it visualized. Okay, while the model is being run, let's recap what we have done. For this tutorial, we just learned how to just manipulate the priors that we have had. For example, sometimes you just come with the prior knowledge of what's going to happen, let's say, for example, with the weights and with the slope. You can then, as a result, choose the family of your experiments. Just go ahead, for example, choose a normal distribution, which its mean is centered at a different position than the thing which comes with the default thing, which is decided by the R itself. And also for the intercepts and the auxiliary, and also we saw that how can we just visualize the posterior and the prior when both of them, they have been, I should say, decided. We can just go ahead with the beta as a parse, which it shows that the visualizations of the posterior and prior with respect to the slope. And also we can change the parse into the alpha, then we get the visualization with respect to the intercepts of the model. And as we are just going to do that in the next couple of, I should say, tutorials ahead, when we have multivariable regression analysis in the Bayesian, and we have more than one covariance in order to make the inference about the slope, you will see that we have, or I should say, multiple points in our, I should say, in our model. And also, the other thing that we just wanted to, it takes some time. I hope that you can just do that. You spend some enough time to do that at home. But let me stop the code here, interrupt the code, and I just go ahead to just do something different here that it's going to be very informative. Let's go ahead and plot the model A. However, I just go ahead with the argument as a histogram. Let's execute this code and see what do I get. And you see that, for example, right now, you have one very informative, I should say, visualizations. With respect to the priors that you have, we have for the priors, we have for the intercept, we have for the weight, and also we have for the sigma, which is the auxiliary, and you will see that the center, which we have, essentially, it shows that the the density of the histogram, which you see that for the weight, we had of, I should say, of 0.3, almost close to that, the inference that we had. For the sigma, it was 0, and also you see that the top of this histogram, it shows that around 30, and that was the thing that we just made an inference about while we were talking on a couple of tutorials before. And also you see that we can also see the 95% of the credible intervals that we talked on both the intercept and also the weight of the arguments that we had. And we talked about the credible intervals in the past. And I thought that, okay, that's going to be a cool thing to finish this tutorial by showing that how you can just plot the Bayesian models that you had. And if you just go with the histogram, of course, you can just have the histograms of the priors that you had. And that's the thing that I just wanted to show you. You can also press F1 in case if you just want to just find more information about, for example, what other thing that they can just put into, let's say, your function. You can always go ahead and just read the example and familiarize yourself with many options that you can incorporate into your plot functions in the RDEP. Okay, now I think that's going to be a good point to stop this tutorial. And on the next tutorial, when you just come back, we just go ahead and just do some more stuff with respect to more arguments when it can be incorporated into our Bayesian regression model.